Department of Electrical and Electronic Engineering and a key member of the Multidisciplinary AI Research Center at the University of Peradeniya. So, to start it off, I would like to warmly invite Professor Lanka, the Dean of the Faculty of Engineering, University of Peradeniya, to introduce our esteemed speaker for the evening.
Thank you, everyone. I hope I am audible to all of you. Mike? Okay, right, thanks. Good evening and welcome to this dialogue. Welcome to this Diamond Jubilee lecture series from the Faculty of Engineering, University of Peradeniya. As you may see, the topic today is AI-driven multidisciplinary research transforming the engineering landscape. Is by Professor Roshan Godaliyadda. And Professor Roshan Godaliyadda, if I may introduce, received his Bachelor of the Science of Engineering degree specialized in electrical and electronic engineering with the first class honors at the University of Peradeniya in 2005. And subsequently, he received his PhD degree in electrical and computer engineering from the National University of Singapore in 2007. At present, he is a professor attached to the Department of Electrical and Electronic Engineering at Peradeniya. His research projects are in wide area, covering signal and image processing, computer vision, hyperspectral imaging, remote sensing and geoscience, smart grid and renewable energy, AI and pattern recognition, biomedical signal processing and bioimaging, computational epidemiology, biometrics, spectral imaging for food and water, quality estimation, smart surveillance, stochastic processes and random signal analysis, and forensics. The whole list and things they are in almost related to that. And in addition, he has been publishing his work in numerous high-impact index journals, such as the IEEE Transaction on Smart Grids, IEEE Transaction on Geoscience and Remote Sensing, IEEE Access, IEEE Journal of Selected Topics in Applied Earth Observations and Remote Sensing, IEEE Transactions on Instrumentation and Measurements, IEEE Communication Letters, IEEE Transaction of Electric and Electrical Insulation, Elsevier Journal of Engineering, Elsevier Applied Energy, Elsevier International Journal of Power and Energy Systems, International Journal of Photo Energy, Education Sciences, Energies, Sensors, to name a few. In fact, Professor Godaliyadda is one of the leading researchers at the Multidisciplinary AI Research Center, or MARC in short, which you find in the first slide of the University of Peradeniya, who is doing cutting-edge research in it. As you may have noticed, the list I pointed out, his publications have landed in a wide spectrum of journals, making him the ideal candidate, ideal resource person to talk about AI-driven multidisciplinary research transforming the engineering landscape. We at the Faculty of Engineering, University of Peradeniya, are commemorating the Diamond Jubilee, that is 75 years of engineering excellence in this country. And I am proudly presenting our resource person today, Professor Roshan, to talk about this transforming the engineering landscape, AI-driven multidisciplinary research. Over to you, Professor Godaliyadda.
Thank you, Professor Lanka, and thank you for inviting me to talk on this lecture series. And this is obviously commemorating the 75th. Sorry. Can you? Check it. This is in commemoration of the 75th anniversary of the Faculty of Engineering. Professor Again and Professor Janaka, who are also fellow members of the MARC team that is part of the University of Peradeniya, also build up a certain sort of theme along which that I will expand on this particular lecture. Right? However, that being said, so the topic at hand is about AI-driven multidisciplinary research for transforming the engineering landscape. So, first of all, what I want to do here is like just go through a couple of the historical precedents. I mean, like engineering history as itself is a very broad field, so I don't think we can do justice for that during this brief time. However, I do want to touch upon some of the things and see whether from that we can learn certain patterns that will help us build the future through this sort of current state. So, right. So, first of all, this is just the main scope of things that I would like to run through. For instance, I would first look at how engineering has evolved and expanded its scope and continues to evolve throughout the ages. And on top of that, I would also like to look at certain pillars that I have identified when it comes to AI itself. What is AI, what its fundamentals are, and how it applies through context awareness towards different types of engineering and other types of real-world problem solutions. And then on top of that, I would also like to talk about how those solutions themselves are then brought towards the general public at large and how it is affecting the society as a whole. So there is like a three-tiered approach to this that I'm looking at, right? And on top of that, I would like to say, especially with the last one that is the thing that I think most are now familiar with when we say AI. Most people are familiar with these generative AI tools. So how that is possibly changing the education and learning landscape. So what I need to very distinctly make clear here is that there is three levels. So first of all, there is the science itself, the computational science of AI. What AI is philosophically, what AI is scientifically. And then there is how we use AI as primarily engineers to solve real-world problems, potentially multidisciplinary problems. And then you have the solutions itself, some of which you have already used, I am sure, going from large language models to image generators to numerous things, and how it is changing the entire landscape. So you have those three tiers. And then of course it changes the education, it presents new challenges, and there are certain types of goals being set by numerous agencies that want us to make sure that countries are aligned with this particular sort of paradigm change. And of course, then what can be done? So that's more or less the broad scope. And of course, here and there I just throw in a couple of statistics. So for instance, here I think it says like global AI market predicted to reach, close to 1 trillion by 2030, so on and so forth, giving tremendous opportunities for developing nations. So this is a common theme that I want to touch upon whenever possible, which is that it is like, if you look at that, I'm not going to look at like large countries, like for instance, if you take China or the United States, but I do want to look at from time to time smaller nations, smaller in the sense of a relative small, how some of those nations were able to tap into certain opportune moments, and through that were able to drive the economic growth. So is there opportunities or at times challenges? So those are things that we need to examine. Of course, before we go into anything else, of course, engineering itself, like somebody could say like, where did engineering start? Of course, engineering probably started with the wheel and the fire and anything where you change the environment to sort of make better your life would be coming under the broad scope of engineering. But I want to go a little bit more into the recent history and start with the etymology of engineering from the Latin word engineer, which means cleverness or innate quality. So what you mean at that time as engineering is you are giving some inherent quality, some inherent value to whatever is being created. So it doesn't really define the whatever mechanism that is being created is of this domain or this domain. It just talks about the inherent value that has been added to it. Of course, if you go down the lane, you would notice that first engineering word being applied is for siege engineers. That is around the 13th, 14th century, so primarily military applications. and hence the partition of civil versus the other engineering fields, where of course around the 1700s you would have civil engineering coming into the forefront with, for instance, Ecole sort of introducing one of the first engineering degrees that was in civil engineering. And then of course you have institutions that emphasizes how, for instance, in this particular case, the institution of civil engineers emphasizes the art of directing nature's power for human use. Right? So you could see, like, you just had this very vague notion of what engineering was at what time, just, you know, making stuff, giving them some sort of innate cleverness. And then, you know, that's interesting given the fact that the topic is also AI, so there is a cleverness there as well. And then it goes into military, as most things always do. So military and war sort of stimulates the growth, and then you see applications in civil and, you know, non-military applications, right? And of course, on top of everything else, because you are looking at the professional landscape, and rather ironically, as we are in ISL itself, we also need to talk a little bit about, like, for instance, like certification, like whether some particular degree has been accredited. So all these things started to originate around the 1930s and all. Here, Engineering Council for Professional Development, ECPD, was founded as the predecessor for EMET accreditation, right? So these things have gradually evolved with the times. That's the main theme that I wanted to bring out here. So you could see that at this time, the engineering fields are well defined. They are very, very clearly defined. And of course, while there is a certain level of interconnectedness, you could see this is generally the landscape of the 19th and the 20th century. For instance, if you took civil engineering, as I said, which started off at Ecole, pioneered programs where you were focused at that time, not now, at that time was focused on like bridges, railroads, and you can see the Great Western Railway as sort of a picturesque depiction of that particular railway system, right? So that type of emphasis was there. Mechanical engineering, interestingly, one of the pioneering universities was the Rensselaer Polytechnic Institute in USA. And of course, focuses were on things like steam engine, machinery, of course, powered by the Industrial Revolution. And electrical engineering, electrical, chemical engineering, both of which seem to have its roots, at least from the sources that I was able to dig up, was primarily within the United States in MIT. And key inventions like, you know, dynamos, and in this particular case, Solvay process, are things that sort of motivated these programs to be started professionally. What I need to make very clear is that this is not the beginning of any of these engineering fields. This is the sort of the professional degree creation point, right? Just putting it out there. And of course, you have manufacturing, and during the Industrial Revolution, once the sort of the mechanisms and the electrical power came in, the next part was the optimization of the manufacturing process, the assembly line, and all of these things motivated things like manufacturing engineering. And of course, then comes the 20th century, and we have computer engineering coming into being, and you know, the computer sciences of it were more or less formalized during Turing's work and all in Cambridge. But of course, you would also have professional computer engineering degrees starting off in MIT as well, primarily motivated by the advent of transistors and the integration of hardware and software systems together. So the bottom line is that you would see this, what we recognize, why I went through this. I mean, incidentally, these are more or less the major fields of specializations in our bachelor's program at Peradeniya, for instance. And you could see how these things came about in the 19th, 20th centuries, and how they became their own little well-defined fields. But come the 21st century, you notice a little bit of fluttering around in these sort of well-defined boundaries. One thing that you notice is that there is these sort of interdisciplinary and merging fields. You know, there are few, I'm just naming a few here because I could name tons and tons of fields if I go through numerous degrees from Europe to North America to even Asia, Southeast Asia. You have so many different types of degree programs and things like that. So I'm just putting some out here. Biomedical engineering, sometimes it's called biomedical and health engineering. There is environmental and climate engineering. There is aerospace, there is materials, there is human-centered engineering, there is agri-tech, there is of course AI engineering itself, and then there is sustainability-related engineering and human-tech collaboration. So that itself is another form of engineering, and we'll go into those things a little bit down the lane. But the point that I want to highlight here is that at this particular point, you could see that just like new sort of specializations were coming about with technology during the 19th and the 20th century, the 21st century seems to be, while one could argue that you are having more and more specializations coming in. Of course, this is my hypothesis. My hypothesis is that it's really the system sort of rearranging itself, where you have sort of nuanced specializations spreading out from a common foundation. So what I would say happens here is that rather than you thinking of different types of specializations here as each of its own sort of independent silo, to think of these things as sort of integrated systems going towards real world solutions, right? This seems to be the common theme that has been observed, at least from the work that I have noticed. And of course, in this case, I just took out IEEE because obviously I'm more familiar with it being an electrical engineer. However, I want to point out a common trend here, which then I will emphasize on a broader scale. Right? So if you look at the way IEEE has expanded its scope from like a single society when it was started to like tons and tons of different types of societies at the current stage, you would also notice that there is also about 200 plus journals. But my point is not about the journals, but the scope of the journals. Now, if you look at some of these journals, you have things that we are very familiar with. You'd have something like the IEEE transactions or power systems, very clear what it's about, right? However, if you look at some of the other things, you'd have IEEE, the journal for instance on computational social systems, or IEEE transactions on cognitive and development systems. Now these are not new. Now for some of those who have been tracking these sort of interesting changes, I can tell you that these journals were popping up for about a decade or two since now, for some time now. So the point that I want to make is IEEE has detected this particular paradigm shift in engineering where it's actually looking at engineering in a broader sense. It's trying to engulf a broader array of problems, and it's actually going back into the origins of what engineering is, which is about coming up with clever solutions for real world problems, which itself is at the crux of the definition of what engineering actually means in a sort of an etymological sense as well. So in this you can also notice, for instance, social sciences being integrated. You have IEEE technology, for instance, for IEEE transactions on education, IEEE transactions on professional communication. So you have all these soft skills, you have all these sort of education related journals. So what this is telling you is that now if you look at any of the presentations that have been done so far on any AI related work, one thing you will notice is even when it comes to industrial engineering is that different types of soft skills are also coming into play, and certain types of humanities, social sciences and other fields are things that have to be confronted by engineers. Of course, as being practicing engineers, I am sure that you all are well aware of this particular fact, whether it is covered in a degree or not. It is the reality of practicing engineering. So another trend here is that if you look at some of the statistics, you can see that 30% of the IEEE journals focused on interdisciplinary projects or topics in 2023. And social tech fields went up to 25%. So I'm trying to sort of show a couple of trends here. On one side, you would see, rather than seeing projects that are like, okay, these power systems, or this is power electronics, or this is communication, something like that, you have these things where you have interdisciplinary topics coming into play, and also you have topics where engineering is being intertwined with social sciences and the humanities. So this is something, for instance, IEEE has recognized for a pretty long time, because none of these journals are actually very new. And of course you have societies, right? You have the IEEE Society on Social Implications of Technology, focuses on the intersection of technology, science and society, including the impact of individuals and communities, right? So all these things, and of course we all talk about like ethics and all these other types of aspects that comes into play when we talk about practicing engineers. So all those things are sort of interconnected in this particular case with an inherent interdisciplinary focus. There is a little bit of interconnection between the fields. Now if you look at the publication data itself, because one thing I normally notice is, of course, the industrial engineering does not always, like in a linear sense, follow the research landscape, but what the research landscape does is it points towards things that are about to come, things that might come about, right? So this doesn't mean like, the main point that I want to make is nothing is like the gospel here, nothing is an absolute, like, okay, this follows this, hence this must be true kind of logic is not applicable. What I'm trying to say here is that these are some of the trends that some of the leading research publishers have noticed, and those people in the industrial sector who can notice opportunities are the people who will most probably gain most out of it, because at the end of the day it is about investing on opportunities while it is still hot, right? So in that sense, now let's look at IEEE Explorer data. So in 2000, 65% of the papers go on circuits and systems. So these are about electrical engineering and And when you go to 2023, you see 45% of the papers are on AI, healthcare, sustainability, and social systems, right? So you can see a massive shift in the way the research landscape has shaped itself within the IEEE itself. And IEEE actually is a journal which, for instance, here I would say like majority of the disciplines would have no problem in linking research to that IEEE landscape. You have research in geoscience and remote sensing, you have research in aerospace, you have research in manufacturing processes. All these things are things that are inherently part of the IEEE landscape. So anyhow, what I have noticed here is this sort of twofold, even though I point it out as a twofold sort of pattern, the way I see it is, it's kind of intertwined together, because once you talk about interdisciplinary approaches and multidisciplinary projects, you are inherently opening up the potential for social sciences, humanities and other branches to come in. And of course, if you take things like AI, which now with large language models is essentially sort of integrating very literature-like, sort of language-like fields into the engineering landscape, I think it is even more so true. So that's the point that I want to at least start off as a premise. Now, let's look at some of the research, because as I was saying, most of the time, research gives you some indication as to where things are going. So in this particular case, when we look at research, one thing you can see is, now if you take academics and industry, universities generally pioneer engineering interdisciplinary fields, while the industry will focus on applying those things into solving of real world problems. So knowledge and experience. Now, so the point that I want to make in this particular case is that, now if you take, for instance, something like an interdisciplinary project, for a researcher, it might just be something of interest at start. Whereas when we talk about it in an industrial focus, we talk about whether it is commercializable, whether it is marketable, whether it is actually addressing the gap in the market, and whether there is some reasonable return of investment for that particular project. So therefore, you would say that there is a little bit more leeway for the researchers to play around, a little bit more narrowing or funneling effect might be there for the industry. However, under that funneling, you would still see astute industrialists would always have a certain level of sort of like, they will have a little bit of a pulse on how the R&D landscape is changing, so that they can see whether there are new sectors that are emerging at the moment. So in that sense, is one of the reasons, that is one of the reasons why I want to talk a little bit about the research side. So now, on this one, let's look at some of the research labs. There is a reason why I want to go into these labs. Now let's take one of them. We have the Sun Lab or the Stanford AI Lab, which focuses on project-based learning and primarily biomedical and AI-driven research. So that's one. MIT also has AI-driven material discovery and all these types of research that is related to AI with practical engineering solutions. For instance, either in biomedicine or in energy or in material science. So these are things that MIT and Stanford have identified as possible areas on which their graduates can have a little better opportunity. Now, another thing that we notice is that when we look at the research, we see people exploring, as I said, untested areas. For instance, computational social science. So what does that mean? For instance, some of you might have heard of words like agent-based models and things like that. What it means is simulating environments. Or you might have heard of the word digital twin, right? Maybe digital twin or the agent-based model, right? So all of those things comes under this big category, right? Where we want to sort of simulate environments and see how certain circumstances sort of unravel in a real world environment. I think a pretty recent and like very close to home example would be the pandemic itself, right? Like if you take the COVID-19 pandemic, for instance, how did the disease propagation happen? How did disease spread? How did vaccination or sort of covering up wearing masks and things like that, did those things really affect the spread of the disease? Or different types of transport restrictions, different types of roster systems in employment. Did any of these things really impact this environment, or was it just guesswork? So what ABMs or agent-based models or digital twins, what they do is they enable you to actually analyze a real-world system with almost a real-world replica of the system, and then you can get to play around with that system in a way that you wouldn't have the luxury to play around with in the real world, because you can't like just drop a disease and see how it propagates and things like that. So obviously we will have to have a little bit more I mean, you will have a more restricted sense when it comes to experimentation. So therefore, digital twins, ABMs, all these things present tremendous opportunities. Now here, that was just on like one problem, but when we say things like computational social engineering, what it also means is things that are very familiar to us, which are now completely interconnected with engineering. One of which is social media. How social media is changing the narrative, how it is shaping political opinion, how it is affecting political campaigns. I think anybody who has followed, for instance, the US political campaigns and the UK political campaigns and all these things that happened recently in the world would clearly know how much of an impact social media has. And I'm sure that you will not be surprised to know that there are entire research sectors dedicated to this side of research, right? Where we are looking at how social systems interact and how media messaging propagates, all these things. So just a few days back, like when I was exploring different types of multidisciplinary opportunities for MARC, one of the potential topics that came about from one of my former students who is now currently working in US in Iowa University was that he was looking at certain types of think of it like political surveys. I think we also do them to some extent, right? We do them to some extent to understand the opinion of people, whether people are satisfied with something or whether something is the underlying cause or an effect of some sort of discontent, right? So I think you know that, like if you take a country like US or Canada or UK, they would have far more frequent polling and they will have a lot of tracking of human opinion on their leadership. For instance, if you take, like if you listen to US news anytime, you would notice, like for instance, okay, Donald Trump's approval rating is going this way or that way, or so on and so forth. So the point is that every time they want to see how decisions, how comments, how, you know, social media statements, everything influence the narrative. So there is an entire science behind it, right? So all these things coupled with like the sort of ABMs that I mentioned all come under that particular category, right? So the next point that you notice in this is obviously the fact that we are gradually seeing huge trends of cross-disciplinary collaboration, right? So that is something that we can notice, and of course there is huge investment of AI into the research and development sector. Even in 2023 it was around those numbers. Now another thing I noticed when I was digging through some of these material is the IEEE Megatrends report, right? So today's AI systems are specialized and narrow. So read the benefits experts say. The widespread adaptation of curated datasets, advances in AI hardware, new algorithms will be needed. It will require interdisciplinary collaborations across computer science, engineering, ethics and philosophy, the report says, right? So this is basically what the IEEE panel, I don't want to go into the details of it here, but what the IEEE panel had actually observed. So what it's saying is that at the moment you have AI systems which are specialized and narrow. You have things that are very good at certain tasks, but not so good at other tasks, right? But on top of that, widespread adaptation of curated data sets, advances in AI, hardware, and new algorithms will be needed. So obviously that part is needed, right? So we will continuously improve all those things, but one thing that is essentially focused on here is that interdisciplinary collaborations across computer science, engineering, ethics, philosophy, all of these things are recommended. That's a key observation, and I just want to show a little bit of a graphic of the insights of the IEEE Megatrends. So you can see here, this is just a pictorial depiction of like what they assume would be like key areas in the future. The axis that they have noticed here, like the x-axis is essentially technology success, right? And the y-axis is the impact to humanity, right? So think of it like this. Now, if you take something like digital twins over there, right? So digital twins have a high chance of technology success. That's pretty obvious, right? Because digital twins are already affecting operation and maintenance of large-scale systems, right? So digital twins is marketable, right? Over here you have generative AI, ChatGPT, etc., smart environments, smart cities, all these things on the red circle over here, right? So these are chances of high success and higher than the impact on humanity. So what is interesting to tell me is like whatever impact that was on humanity by these things is lesser compared to some of the things over there where there might be at the moment probably not that much guaranteed technological success. So this is like telling people, if you want to be safe and make money, be over here. If you want to be adventurous, go over there. Right? So what's over there? Like I think I can see like genomics, DNA, molecular medicine, then for instance decarbonization, wearable implants, computer-brain interfacing, so all those things. Then in the middle you have like healthcare, electrification, autonomous robotics, things like that. So the point that we need to get out of it is like, there is like, for instance, like the technology that we see at the moment as something very cutting edge that is impacting humanity, according to the megatrends, while it is still pretty much impacting humanity, there is lot more things about it, right? But some of those things are not exactly guaranteed of technological success. So if you are like an industrial engineer, then what you would probably like to focus on is around the red zone, because probably these are places where there is no guarantee of technological success over here. However, there are some opportunities on that other side as well, but generally what happens is like you would have the larger funding bodies, like things that can handle large research grants, will probably focus on those areas, and once they are guaranteed of success, they will sort of funnel through here. But anyhow, the point is, in most of these cases, you will also notice that it's not like a well-defined area in our traditional sense. Like if you look at some of those topics, right, because this is basically the IEEE mega trends recommendation, right? So if you look at it, like of course some things are familiar, like clean and renewable energy, healthcare, ubiquitous connectivity, communication, cellular, smart environments, and you have energy storage, you have decarbonization, sustainability, all these things, right? So, but of course, they are not within the same sort of well-defined specializations, but some of them are familiar, some of them not so much. However, I think it showcases a little bit of the thinking and the planning that is going on when it comes to how to understand different types of strategies and all that. Okay, I don't know what that red line is, but anyhow, let's go into the AI pillars. So the AI pillars that I wanted to mention is, because like when we talk about AI, different people, for different people AI means different things, and I actually want to be fair by everybody. Right? Because actually AI is kind of all of those things, right? Because one of the things has to do with like AI in a very algorithmic sense, mathematical sense, foundational sense, what AI is, right? What is inherently AI in a very theoretical sense. The next thing is what AI is for engineers and problem solvers, and how do you use AI to solve real world problems in novel ways, R&D, right? And the third one is obviously how existing AI technology can be used in a broader sense, as I was telling before. And of course, when it comes to, I do want to introduce MARC in parallel. MARC, which as we just mentioned, is one of the organizations that I am attached to, and it is under the University of Peradeniya, Multidisciplinary AI Research Center. And of course, as you can see, we already look at it in a very multidisciplinary sense. We want it to be a center which sort of has interconnectivities with all the multiple fields of like study that is there in the university. And of course, you can see that they are not exactly divided according to the faculties. We are just looking at them as trust areas: engineering, management, education, climate change, healthcare, agriculture, so on and so forth, right? So you have those kinds of trusts. But what I want to showcase is MARC actually looks at all three pillars over there. That's the point that I want to make. If you take some of the MARC research, they are very theoretical, they are very algorithmic oriented, they are very foundational. So we look at the math, we look at the theory, we look at the science behind the whole thing. But then we also want to be sort of technologically innovative, right? So therefore we look at the second tier as well, which is multidisciplinary and interdisciplinary approaches for real world problems. You will see some of them. I don't think we'll have time to look at all of them. We'll just look at some of them. Of course, we have another huge component which involves, for instance, what we are doing now and many times over and over, which has to do with, for instance, capacity building, AI awareness, and effective use of technology and making the general public, professionals, students aware of it. And there is numerous internship programs, volunteer programs at MARC, where not just Peradeniya students, but school children, pre-engineering children, as well as numerous universities from local and foreign coming in, volunteering, interning at MARC. So all these opportunities are there as well, right? And also there is the sort of project-based learning approach to everything as well, right? So keeping all that in mind, let's look at some of the statistics, right? Because whatever it is, it reinforces an argument better. So here, an NSF study in US has said that interdisciplinary teams, right? That is teams with more than 3 fields in that team, right? So the team has to have at least 3 or more fields, have generated 2.3 times more patents than homogeneous teams. So that's kind of obvious. Even on our way from Kandy to Colombo, we had this particular discussion about how this is like just logical. Forget about the statistic, right? Because at the end of the day, what is fields? Fields is perspective, right? So if you get more perspective, you get to innovate more. Because bottom line, if you talk with people who are highly correlated with you, as information theory would say, you are not really enhancing your dimension. You are just there because you know what the other guy knows, right? If you are within the same field. But if you are talking to people from the other fields, you learn things from new angles, you learn new knowledge, you learn new perspectives. So therefore, obviously, this is there. Similar studies, nature study, 35% higher citations for papers from interdisciplinary projects, right? So higher patents, higher citations. 1.7 times more likely to publish in top-tier journals such as Science and Nature, right? So obviously, Science and Nature are inherently interdisciplinary, they are inherently multidisciplinary. So that clearly sort of combines that argument well. And of course, I'll just keep on reading a couple of stats just to hold it in. Right? The World Intellectual Property Organization reported that 60% of AI healthcare patents filed in 2022 listed investors from 3 or more disciplines. Right? So to get a patent, get something to be really commercializable, you do need that whole interconnected team. Right? For instance, here example, concerns biology and engineering. Makes sense, right? So that's it. Then, for instance, if you take MARC alignment here, so let's mark over here, right? Computation methodology, what I just said, for instance, combines agent-based models in computer science and computer engineering with public health and community health and data science and data analytics, right? So you have all these things coming in together. And of course, I think there are a few more statistics here, but I do want to look at, this one, the last statistic, which I think is of importance because it's about money, right? Funding trends. NSF's Convergence Accelerator prioritizes team blending 3 or more teams together, and the budget is over that amount, right? So the point of the matter is that whether it is a granting body, all of these people recognize the success of interdisciplinary approaches and hence the approach, right? And of course, that's something that we want to sort of hopefully successfully emulate. I just want to give a sort of quick shout out to some of the people here, like the real workers are actually the people who are the RAs and the volunteers. And on top of that, we have the entire team as well. And as I mentioned, for instance, some of our earlier speakers like Prof. Prof. Ragel are also there, and some of the people in the audience like Prof. Barak is also there. So many other people are there. These are just the core team members. Now remember, we have collaborators from Faculty of Agriculture. We have collaborators from the Faculty of Medicine. We have collaborators from the Faculty of Allied Health. Right? So all these places, and this is just me, I think it was an idea that we put together to put some of our projects into a word cloud, just to show how much of a scatter array of areas that is there. This is just a glimpse of what we are doing because we have actually branched out even more. And here are some of the pillars that we focus on: digitization of data, multidisciplinary research, outreach, and training. Right? Because at the end of the day, training feeds into research, research feeds into outreach, and data uses research. So they're kind of interconnected as well. So that's the approach there, but I don't want to go too much into the projects, but I just want to put it out there just to show you what I meant by the pillars. Like for instance, this is primarily projects that are focusing on fundamentals. They have applications, but the fundamentals are the focus here, where we are not thinking of the application when we are doing the algorithmic design, right? So here you have what we call denoising diffusion probabilistic models, DDPMs, implicit neural representations or INRs. Right? So these two I want to pick because these two are things that are making huge investments. Like researchers across the globe in US, China, in Western Europe actually do invest in these things. DDPMs is a technology that is highly dependent on high quality image synthesis. All these image generators, right? So for instance, I think I forget the name. There's an image generator which actually has diffusion in its name, standard diffusion or something. Yeah, I think it's standard diffusion, right? So basically tells you that diffusion, standard diffusion, right? Stable. Huh? Stable diffusion, sorry. Stable diffusion. So stable diffusion is one that actually uses the DDPM concept. So we want to improve upon them. INRs are important because it's about data compression. It's about data storage. It's also a big problem, right? So how do you compress data in an effective way? So those kinds of things are there. And of course, these are just glimpses into those sort of worlds and algorithms. For instance, drug discovery, we were talking with some of our collaborators, foreign collaborators on how, MIT uses it as well, but how drug discovery can be helped through diffusion models and denoising images, all sorts of biomedical applications and pharmaceutical applications are immense in this particular field. So if you know the fundamentals, then you can link them to the application. So that's one. Yeah. Okay. This just showing stuff, right? So this is the implicit neural representation, right? It's about how we actually represent objects in a compressed manner without losing most of the, not most, actually any of the information, so that we can actually recover it effectively. An implicit representation of anything is nothing related to AI. Implicit representation of something is implicitly what an object is. What does something really mean? What is the sort of the most reduced interpretation of something, right? And that is what you attempt to capture here. For instance, when you look at these images, you hopefully think that the object is an object, right? So, for instance, how you represent the object, right? So, therefore, it helps in like imaging painting, resolution, enhancements, denoising, compression, all these things, right? But these are just fundamental projects that I just want to put out there. Now, these, for instance, are a little bit more application oriented, right? So, here, AI engineering for food and agriculture, right? So, food and agriculture, broad topic. We have collaborators from the Faculty of Agriculture that are working on these. Some are actually from the Department of Botany, right? So we look at things like aflatoxin contamination in food, we look at adulteration of turmeric powder, we look at the impact of reheating of coconut oil, all these things using devices such as multispectral devices and things like that. But the point of the matter that I want to make here, rather than the research itself, is that here, now we have something, but we actually don't know the problem. The problem is given to us by the Department of Botany or the Department of food engineering or whatever in the Faculty of Agriculture, right? So the point is, we have certain solutions, and these solutions can only become more effective if we have the actual problem handed to us from somebody who is facing that, right? So I think this particular example goes beyond that in this particular case, right? AI engineering for medicine and healthcare. In all of these, I think, there are three in focus here. One has to do with preterm birth detection, like when mother's muscle contraction happens, how do you detect whether there is a risk for preterm birth? The other one has to do with like fetal activity, whether the fetus is in good health under the mother's womb. And the other one has to do with imaging and oral cancer detection. To my knowledge, all three of them were initiated as a problem from the other side. What I mean by the other side when we are in engineering is basically the other side of the river, right? So there is faculty of dental sciences or the faculty of medicine, right? And electrical or computer, mechanical or whatever the engineering sort of coming together with them to solve the practical problems. For instance, in this particular case, I remember very well, it was a practical problem presented to us by the Department of Obstetrics and Gynecology, where they were genuinely concerned about those two problems causing numerous health risks for mother and baby, right? And clearly, for instance, I think anybody would know, like for instance, when it comes to fetal health monitoring, what people do is they just manually count kits, and sometimes people forget, and sometimes things are not tracked effectively, and problems occur, right? Of course, I don't need to even explain the importance of preterm birth detection. Anybody who has had a child would clearly know that it's a pretty serious problem, right? And oral cancer obviously is a uniquely key problem for Sri Lanka, and there are numerous factors associated with it, and the group that was the computer engineering department coupled with the faculty of dental sciences that came up with it not only have created resource solutions but have created large data sets, and data sets by itself are money. That is something I think we really need to sort of probably convey to the public more than anything else when it comes to AI, because AI is only as good as the effective data it sort of utilizes. So collection of data, curation of data, all these things are a valuable asset, and that's exactly why it is important that we have a certain level of access. These just, I'm not going to go into the algorithms, just showing you like these tremendous applications in geography, geology, civil engineering, which has to do with geographical information systems, where we use hyperspectral imaging for land cover mapping. Key point again is that one, why do you need interdisciplinary? One, let's say the other side will bring in the problem, that's first thing. Then we have algorithms and we solve the problems, but then they also give us context. So what I mean by context is, now we don't know exactly how oral cancers manifest. We don't exactly know how, I mean, we think we know certain things, but we really don't, because they are not our expertise, right? So for instance here, when we talk about land cover mapping, again, somebody who is attuned to that in geography or geology will have unique insights on how land cover texture propagates in an image. So what we do is we get that insight, that contextual domain knowledge from them, and we adapt it into the AI algorithm in an effective way. So what you are seeing here is AI sort of connecting fields and bringing context to engineering solutions, so that you don't have what we call one size fits all solutions. You have solutions which are contextually adaptable to each and every environment or each and every problem. Wearable technology, right? I think I mentioned it earlier in the IEEE megatrends as well, right? Already there is huge interest, for instance, from the Ministry of Sports, as well as certain types of volunteer organizations that's focused on prosthetics and rehab. And of course, there is, like the sports applications, there is tons and tons of applications there. Now, when it comes to tracking motion, there is two ways to track motion. One is through wearable technology, as mentioned here. The other one is through computer vision, through cameras. Now, you need to know that both are important and both can solve two different types of problems, right? So therefore, you have to continually sort of adapt two domains of problems and continuously move those things together. And here, interestingly, we found new collaborators and they brought in new problems. That's exactly what I meant. Like for instance, when it came to the women's health and the sports applications, we started recently to work with the Allied Health Sciences faculty, Department of Physiotherapy, if I remember correctly, and they had certain unique insights. For instance, we would say, okay, this is the way people walk and this is how the ankle bends and the knee bends and all these things, and these guys will say, no, there is this muscle group that is acting against this muscle group that is creating this event and this will lead to back pain, right? So I'm like, how does this thing add up? Because that's exactly why you need the other field, right? So these guys bring in those perspectives. We deal with the angles and rotations and all these things, and they give meanings to those numbers, right? So that by itself I felt was interesting, and also sports and one of the primary motivations behind me going into this actually has to do with my youth. Like for instance, I think for anybody in my generation who grew up watching cricket, I think 1995 is it when Murali was called for Chucky. Right, and that's when like biomechanics became a field for me, where like, okay, like how do you really properly measure the shoulder bend and all that, and that actually has been my motivation towards these projects, and that's why there is a sports arc to it. And in the sports arc to it, we notice that when people are trained, how different motions affect different people differently. Like now you have a good table tennis player. What we did was we got a bunch of people who are not so trained, and we just told them to play the shots, right? We gave them a little bit of instruction and they would play the shots. We wanted to notice what were the key differences people were doing in their technique. So what we noticed is that there was two things primarily wrong that two different groups were doing. One had to do with the wrist, one had to do with the shoulder, right? So these common changes or common deformities can be properly analyzed as well. Again, similarly, you have a lot of AI applications when it comes to social sciences. This was the one that I was telling earlier that has attracted a lot of recent interest, where when you have a lot of large number of data sets and surveys conducted. Now, the key point is earlier, statistical analysis was all about numbers. Now with AI, in the sense like large language models and all that, the survey could be easily interpreted even if it is represented to us in the linguistic form, like language form, right? So all this data can be analyzed and they will give you insights into policy in a data-driven. So what I mean by that is we don't assume that this policy is good. We see whether the data actually reflects. For instance, we conducted huge surveys on socio-economic impact of the pandemic, and we looked at how it had affected people when it came to education, when it came to psychology. And we did a lot of collaboration with the Faculty of Arts, that is the Education Department and Psychology Department, and we actually used sort of pretty novel unsupervised clustering techniques coupled with their own insights on education and psychology to come up with, like, for instance, what happened. Like, for instance, in one of these we noticed that during the pandemic, like if you took social media behavior, like how people were affected by social media, one thing we noticed is that, like, the way social media affected people was more aligned with factors that were similar to like substance abuse or alcohol or things like that. So what this is telling you is that people used social media as a coping mechanism, and it was published in the Frontiers in Psychology, right? So that finding was data driven, and on top of that, if you take educational impact, we again noticed interesting things. I am not going to go into all the details, but it talked about how income level affected the online education effectiveness. Now, somebody might say, okay, now we are not going to, like, pandemic is over, but clearly we all know that online education is happening a lot, right? So I think it is important we study the impacts in a data-driven manner. So these kinds of things also sort of open itself up. And I think ABMs I mentioned earlier also, right? So this is still on policy and social sciences, how AI is affecting governance, policy, socio-economics. We also have some collaborations with community medicine, where we try to look at how population demographics affect diseases, things like that. So that's one side of it, and the other side of it has to do with human motion capture. So we study how humans sort of move about, right? Like, we get a little bit of an idea about the motion patterns, and we model them as agents. We see how humans interact with people, with other people, right? So then we use those models to see, for instance, what would happen if a disease comes, right? Like I said, we are not allowed to actually infect people. So what we do is we infect the simulation, right? So there, an interesting insight came to us when we talked with the epidemiology. That's it. Like, for instance, now COVID is still there, interestingly, by the way, but anyhow, while it is there, let's also upgrade the model to incorporate vector-borne diseases like dengue, right? So that has also been incorporated in the model. And of course, these things cannot be done by an engineering team, right? We obviously don't understand all of those things. We understand the mathematics behind it, we understand the software behind it, but we don't understand the disease propagation mechanics. So for that, we need collaborators from the other side. Okay, so I think that's just a glimpse of stuff. So then we are kind of trying to conclude on it and look at it and see whether there are some global trends and things like that, right? So there is this phrase of like AI engineering, and it's about like using AI solutions for specific real world problems, exactly what we have been doing, right? So that's pretty much clear, right? And other thing that we need to notice now, for instance, here you can see, if you take some examples of such situations, I was talking about AI-driven predictive maintenance in manufacturing can boost equipment uptime, reduce maintenance costs, right? So that's one example of an interdisciplinary field coming. Another one is digital twins and analytics engineering. Virtual models of physical systems use AI to simulate and optimize integrated processes in real time, right? So the early ABM was like off the grid, but you can actually have a digital twin that is real time replicating certain things. You are connecting an IoT system, and the Internet of Things network is actually feeding real time information into this guy. So it's like actually affecting things real time, right? So bottom line is you can have that type of simulated environments, and you have obviously computational social science and things like that, right? So Sri Lanka as a global south country obviously faces unique challenges when it comes to resource constraints. That's obvious, right? So therefore we have limited access to advanced technology. All that is true. So the model's focus is on context-specific AI solutions to address these challenges that aligns with the need for inclusive, scalable technologies in developing economies. So what I mean by that is, think of it like we can only focus on investment to so much. So therefore, like actually making it very specific matters. So I don't think like people can come up with like a real good answer like, okay, this is the exact field that you need to invest on. But what it's telling you is that we really need to be much more careful than other people. It's not a luxury for us. So we really need to do that. And a couple of other things, let's look at that one. China's AI Innovation Action Plan supports AI engineering through interdisciplinary research teams in universities targeting AI integration in various fields, right? So that's essentially, a lot of people are talking about China's AI investment. Of course, nobody is going to emulate what US or China is going to do, but still, you see directions there, right? So, for instance, here, you can see the interdisciplinary concept is very much sort of intertwined into their philosophy as well. And this is just me showing a couple of small countries that, not exactly small, relatively small, right? That sort of invested on certain things at the right time and then continued to do it in a sustainable manner to stimulate growth. Like usual suspects are there: Estonia, Ireland, Taiwan, South Korea, right? So I don't think we need to go like one at a time. You can pick something, like if you take Ireland for instance, right? Huge investment in higher education. This is something that I obviously fascinated me for a long time, because like I mean, for a country that was like in the 1920s very much like aligned with the economic standings of the global south, to come up as probably one of the most developed countries at the end of the turn of the century and now early 21st century. It's very interesting, and their approach was novel. They had like, the one thing I always notice is that none of their approaches are single-pronged attacks, that they are multi-pronged attacks that sort of fall on itself and somehow keep the system propagating. So, for instance, here they invested in higher education, they invested in English skilled labor force, and aggressive foreign direct investment, strategy targeting US tech and pharma companies. So, that was their opportunity, right? They just looked at, okay, this is where we need to invest, went all out on that, right? Estonia, early investment in digital public infrastructure. Right? So that's an interesting one, right? E-government, EIDs, first country to offer e-residency for digital entrepreneurs, right? So anyhow, and you also notice about United Arab Emirates, Uzai University, which actually had in 2019, I think the number one AI citations for faculty in 2023, right? And what is interesting is this, I'm not going to go into detail on the university, but what I want to point out is the next line. What does the next line say? The first line says, very, very research-oriented academic statement, right? UAE's Mumbuza universities who became number one in AI citations per faculty. Right? So that means the faculty is doing a lot of research and citations are coming. What is the next slide? Abu Dhabi's AI investments grew from 200 million to 1.5 million in 4 years. Right? So why I say this is because reputation matters. Right? Like when people invest in people who know stuff. Right? So I mean at the end of the day, citations have numerous impacts. One of the impacts is the research itself, but another impact is telling the world credible work is happening over there. Right? So that's also another interesting thing I noticed. And let's see if there's something interesting here. This is about the Stanford labs. This is an interesting statement I really like. Right? AI for medicine, robotics, and social sciences. AI must integrate clinical expertise, not replace it. Right? This is something many of our colleagues have told a lot about the human in loop AI, context-driven AI. It's not like people coming in and replacing whoever the experts are. It's more about the experts being enriched by an AI system and the two of them working in cohesion, hopefully. But does that mean that everything will be clean and spotless? No, problems will happen, and people will point those out. Autonomous navigation. This accident happened over there. First, when the internet came, tons and tons of problems. You can't say that the internet was a nice place, and you can't still say the internet is a nice place, right? So that doesn't stop the world from having the internet. So therefore, we need to look into those kinds of things. And also, I think last couple of slides focuses on research trends and challenges, right? So one thing that is interesting is that if you take North America, for instance, most of the AI PhDs went to the industry. So that's an interesting observation, right? Like for instance, when we talk about like degrees and their alignment towards the industry, that when you see that a PhD holder is highly valued by the industry, it tells you about the industry as well as the PhD. It tells you about a bit of the both, right? So that's an interesting point. Right? Computing power being used by the industry is larger and has grown more rapidly than that is used by the academia, 29 times bigger on average, right? So this is an opportunity and a problem both, okay? You will already see this because like with AI, that's another huge danger, and it's a complex topic, right? But what I want to tell you here is that there is this situation where bigger gets bigger, right? So we need to be vigilant of those things as well. So we have to look at all sides, right? And of course, AI is simulated and they all do and all that kind of general statistics can be noticed there. But another interesting statistic is something you all know, but I want to repeat it because it has a significant message. Yeah, sorry? Yeah. Definitely. Actually, AI was there much before, but the issue was like it's about like how things picked up gradually, and AI, the way I normally use it is like AI became more mainstream, right? You could use the word better. Anyhow, going back to this thing, Google Brain researchers developed transformers, a type of deep learning architecture, and this was an important step in basic research. Anybody who knows AI theory knows this, right? However, what is interesting about that is, it's not exactly academia, it's kind of industry. So what I wanted to mention here is that industry, it's not the typical industry, it's the AI industry, but it's the industry that came up with some novel solutions. But there are some warning signs that MIT report and some other recommendations mentioned, which I think is kind of relevant to us as well. So let's look at them. Built-in public data sets, of which there are no intermediate commercial interests, is important for the creation of tech AI researchers in academia. So what we are trying to say here is something like this. Now, if a certain research sector is entirely dominated by an industry, sometimes it is entirely profit driven. So there has to be a balance. For instance, there should be a certain level of investment on public interest data. For instance, will a certain company have the incentive, the profit driven motive to look at, okay, let's bring up the education level in the rural community. So something if there is no incentive, right? So therefore we need to look at those things as well. So the point is, when it comes to any field being introduced, any field has pros, cons, straight opportunities, all those things, right? So next one, industrial domination of applied work also gives it the power to shape the direction of basic research. Right? So that's another point. So that's where academia also has to work with responsible industry, such that it is not done at an exploitative level, and it is done at a level where there is some benefit to the public good, right? So that's another recommendation. And of course, some initiatives have been done when it comes to pooling of resources of academia, where people have realized, like in USA and Canada, sometimes you have to pool. This is not Sri Lanka, by the way. Like US and Canada have recognized that for them to compete with the industry there, that sometimes universities will have to pool resources such that they will maintain a certain level of competitive advantage, right? So those are things, and obviously you can see this is basically the H5 index of all publications, right? And number one is obviously nature. I'm not sure, and this keeps on fluctuating, but this gives you a general idea. Second one over here is CBPR, that is an AI conference. Actually, everything that is highlighted here is an AI related conference actually. But what is in between? Nature, New England Journal of Medicine, NatureCom, Lancet, Cell, all these types of environments. So all the fields, every other field plus AI. So you can see the huge impact of AI on research as a whole, right? So of course, this all means that when it comes to education, we also need to be aware that we need to realign these things in a way that we create education systems that are sustainable under the given change. Because whatever it is a change. It might be a small change, it might be a big change, but it's a change, right? So therefore, one thing that people notice is that there should be a focus on exploratory and interdisciplinary education, project-based AI integrated learning, and board being syllabi to prepare students for their AI futures, right? 60% of syllabi will be obsolete in 5 years. MIT's 2023 Future of Engineering Education report, right? 70% of global universities plan to integrate AI into the curriculum by 2027. Another education, right? So let's look at some of these things, right? So for instance, how certain universities have adapted to this particular landscape. Now look at Carnegie, for instance. Carnegie has used AI engineering where they use real-world solutions with project-based focus. So this sounds kind of familiar to what we were just talking about earlier, right? So for instance, Carnegie Mellon, one of the leaders in computer science research, right, focusing on the fact that project-based solutions with real-world applications are things that we need to focus on. ETH Zurich, again one of the highly valued physics, has what we call AI plus X degree programs, so hybrid programs, which combines AI with another field. So you would have AI with medicine, AI with architecture, AI for planning, right? Something like that. So you would have this kind of sort of interdisciplinary programs coming in, where you have what we call a diversified portfolio, and we are kind of experimenting on this in Peradeniya as well, where in addition to the majors like the electrical, civil and mechanical, what we want to offer are minors, and minors we want to offer in areas which are probably niche, probably trendy, so that we don't harm the core syllabus, right? So the core syllabus will continue, and you would have an AI minor. So think of it like this: you can do a mechanical engineering major, and you can concentrate on something in mechanical engineering like mechatronics, while minoring in project management, right? So you would have a more diversified portfolio, because actually what we have noticed from the current demand trends in employment is that you do want those sort of everybody to have a good base, but then people to then at the top be adjusted a little bit this way or that way, so that they can slot into different types of areas. So for instance, an O&M engineer might need to be aware to do predictive modeling, right? Something like that. And India's AI for All initiative also has industrial labs linked to it, and this is basically the final slide. And what it's saying in a sense is, you want to manage your own choice of society, your choice of civilization. You have to be able to be an active part of this AI revolution. For many countries, the scale needed for these types of investments may be daunting. In such cases, the key question for policymakers will be whether they can pool sufficient resources with like-minded collaborators to reach scale needed to create AI systems that reflect their own priorities. Do not let our priorities be governed by other people. And also, for policymakers working on this problem, the goal should not be that academia does a particular share of research. Instead, the goal should be to ensure the presence of sufficient capabilities to help audit or monitor industry models or to produce alternative models designed with the public interest in mind. So that is important, not just to be profit driven. With these capabilities, academics can continue to shape the frontier of modern AI research and benchmark what responsible AI should be like. Without these priorities, important public interest AI work will be left behind, which is one of the final concluding recommendations of the MIT report on the future of AI as well. Right? Okay, thank you very much.
Alright, so I think we can move on to the Q&A. So first of all, we'll be opening the space for everyone who is physically present here. And at the same time, we do have a set of questions from Zoom. But first, if there is anyone who has any questions, can I see their hands? Alright, so until that, we'll move on to the questions in Zoom. So we have one question from Upeka. It says, is AI all about making more accurate decision making in respective fields?
More accurate decision
making in respective fields.
Well, actually, any engineering field should strive towards making more accurate predictions. I would hope that AI would facilitate it, right? So, for AI to probably facilitate in that particular problem, my message is to probably have context experts. Not to let AI do the whole thing, but AI enrich the context expert.
Alright, anyone else here? Please do raise your hand so that I can come by with the microphone. And we do have another question in Zoom. So it says, AI systems require significant processing power. As AI continues to advance, could you elaborate on why increased computational resources are necessary and discuss the potential role of quantum computing in enhancing AI capabilities in the future?
Okay, so first of all, when it comes to computational resources, I think it will be a common problem, and I think that's what I was trying to point out over there, right? Quantum computing might have a potential opportunity, but very much like high infrastructure, both of these things, before quantum computing even, our own resources are pretty limited, as whoever is pointing out the question is very correctly saying. So therefore, this is exactly why I said, like, we investing is a common problem. I think some of our own authorities that are like tasked with like how to invest our funds on AI development are facing, right? For instance, how much do you invest on infrastructure? How much do you invest on research? How much do you invest on skill development? So it's not an easy question to answer. But the point of it is that there is always a little bit of ingenuity associated with it. I'll give you a quick example, right? Now, for instance, if you take DeepSeek versus ChatGPT, I think that gives you another nice example there, where a problem was presented to those researchers that were working on DeepSeek, which actually made it an opportunity. So I'm not going to go into the theory of it, but what they essentially did was they came up with novel linear algebraic and theoretical solutions, right? That actually was able to overpower some of the computational resource restrictions they had. So my point is probably try to focus on areas we can. For instance, data, right? I was saying data is money because people don't appreciate the value of data because it doesn't seem very glamorous, like, robots flying about or whatever. But the point is sometimes the money is in the details. So therefore, I would personally encourage people to invest on data digitalization. That's a key part. And maybe use already trained AI models and then adapt it. There are concepts like transfer learning and things like that where you don't need to do from scratch training and build on systems that are already there and adapt them to different environments.
Alright, so is there anyone here who would want to ask?
Do you have any experience reported use of AI in economic controls, policy in economics?
You mean like economic policy making? Yeah. I have one example, but I don't know the extent of AI in that. Right? When we were digging for agent-based models and their applications, I noticed that there was actually one of my RS found it. There was an application where agent-based models, in conjunction with possibly reinforcement learning, was used in financial policy and decision making by US Treasury or something related to that, the US government itself. So they have that models running, but unfortunately, I don't think you will be able to get into detail. But the point of it is, because if you take these, like, we didn't even touch on that topic, but if you take reinforcement learning, it's all about like maximizing different types of rewards based on like the things that have been defined for you. Like for instance, people are saying, okay, you need to be innovative, or you need to be very cunning or ruthless or whatever. So your AI system will try to maneuver the system in a way so that it does it in exploitative. I notice this, like when you do video games design, AI itself they are using AI, and you can design AI to be highly exploitative, so that they will just hook up the marks or whatever. So I think it is already there. I only noticed that.
That's fair because things are not integrated social.
Definitely. Yeah.
We can use the advantage of AI to have more realistic, like fourth angle.
Exactly. I like telling you, like in my case, I think we in the sense the secondary, primary, tertiary education itself. That's why I think, like for instance, I wanted to promote the MARC kind of model. I'm not saying just MARC is fair or whatever. I'm trying to say is that promote this kind of model everywhere. Is what I'm basically trying to say. Is that because there is a lot of lack of connectivity between these fields and a lot of distrust and like I know better than them kind of an attitude. And actually, in a way, it's true for everybody, right? Because like for instance, if somebody is a field expert in area A, another one is a field expert in area B, obviously both of them know more than each other but in different fields. But the point is getting to communicate and to make sure that those goals are aligned. So for instance, I think the fact that we make a huge early partition in our social sciences to the STEM fields might be one of the reasons why, for instance, our like our administrative hierarchy goes on a completely different sort of educational qualification framework, and we go on another framework. So if there was a little bit more integration in that, maybe there will be more opportunity for collaboration. I don't know, but it is definitely beneficial.
One more thing, one last thing. The whole call about digitization.
Mm-hmm.
Does this AI has some role in digitization?
Yeah, like for instance, what I mean by that is like to be honest, I would encourage like for instance digitalization of material, but of course we will have to consider privacy issues as well. It doesn't mean that we put everything into data sets or whatever. But I was just having a conversation with one of my colleagues, interestingly from the medical faculty, who has a huge interest in like language studies, and he was pointing out to me about like old literature that is generally being lost. And he was asking like better ways to use LLM systems to sort of integrate that into the sort of like data sets so that we can do effective studies. And actually we are kind of going in that direction. We actually try to see whether we can, like normally what we have done in AI is we have used language studies logic to build AI systems. But what I am saying is can't we like use AI to make insights on language studies. So for instance like patterns of language behaviors and things like that. So the point of to answer your question, the more data that we can digitalize and curate in like in a very proper way, not in an improper way, not in an exploitative way, would definitely affect better decision making. I just have one example for this which I really liked, which had to do with the fuel quota system where we had a QR code, you might remember, right? And I was thinking like when the QR code was done away that it was a little disappointing because I felt that like by maintaining privacy, we could have had an idea about like how energy consumption patterns were actually traversing throughout, because we are an energy deficit country. So the way we kind of spend energy, rather than making assumptions on how energy is sort of trickled through the system, if we had certain digital twins, so as to speak, to see how our money is trickling down and whether some of that is being sort of properly invested in manufacturing or anything that stimulates growth versus is it a money hole, right? So things like that could have been. Like, I felt that it was lost also. Yeah.
Alright, so I'll take another question from you. So, can AI make more accurate decisions using lesser data?
Yeah, that's a pretty general statement, right? Obviously it can, right? But it requires DeepSeek is, I'm just telling, right? So things can do things better with less data compared to a previous model if there is more cleverness. The whole engineering Latin word comes into mind here now. So that's all engineering in my opinion, right? So the better engineering you do, the better things you get out of a given system or less resources.
Answer should be under solution.
Yeah, it's under the definition.
Alright, so the next question is, what are the AI research organizations available in Sri Lanka?
AI research organizations. well, I do not think I have a list of AI. I would typically assume that all the universities are doing pretty good AI research, but my personal advice is to actually go through like certain research centers and see which is there. Like for instance, MARC is doing AI research, for example, but I don't think I can remember all the names. Yeah, MARC, yeah, Multidisciplinary AI Research Center inside the University of Peradeniya is one, for instance.
So anyone here who will that?
Yeah.
Research position, sir. So it's been appreciated hearing speaking. So my question is when we are talking about the implementations, it's always we can avoid discussing the possibility of AI bubble.
Yeah, definitely.
So it's in academia and industry,
Yeah.
people are always talking about it.
Definitely.
So are we heading towards a bubble?
Yeah, definitely, right? I mean, it should be in a way, like, I mean, the bubble is something which it's a weird thing, right? Like if you know that you're on a bubble, are you on a bubble? Right? It's an economic philosophical question kind of a way, right? So it's more like how much, I mean, the way I'm not an economics expert and I don't claim to be, the way I understood it is, like, for instance, how much more can you game the system? Right? Like if you take the investment bubble in the United States, it's more about like how much were you willing to sort of milk it, right? So that's the point. Like I think you made a very good point, and it connects to another broader point, which has to do with like bad actors and bad faith arguments, right? So for instance, like when we talk about AI, are the people that are talking about it responsible, and more importantly, the people that are using it responsible. This connects back to the last couple of slides that I was mentioning, where is work done in the interest of public good, or is it done properly in an exploitative manner? Because the general way that economic, again, not an expert in that area, generally should work is that things tend to get out of control when you sort of exploit it in a sort of very snowbally kind of way. That's probably the way I would look at it. So the main thing, like if you go down the lane, like that's why history is so important, right? If you go down the history to any tech revolution, you would see people say, oh, this technology can do this. Ultimately, out of 1,000 possibilities, they ended up doing like 25 or 30 that were like sustainable, right? So of course, we should have controlled expectations for anything, but there is no denying that this is having a broader impact than some of the revolutions. Maybe I don't want to compare it between the 5 industrial revolutions which has the bigger impact, because like the first one had a pretty big impact that now people don't remember it because it was like 200 odd years ago, right? But it changed the entire landscape from feudalism to the modern world, right? So I don't think anything will do that kind of revolution. Who knows, right? But the point is, like, always check yourself, right? Like, is this going a little bit too far? Is this just a silly investment, right? So that's why I said, like, especially when we have, as a community, limited money, we have to invest responsibly, right?
So I would like to frame this in a better way. So working in the government institution itself, in transportation, we have a big issue in terms of data digitalization.
Okay.
So keeping that as a barrier in our incorporation of AI, or even the basics of AI or ML itself, bringing it into the transportation sector, public transport is a very big barrier. So when I talk to my colleagues abroad, they are in a different level altogether.
Definitely.
So can MARC your multidisciplinary body or
any other,
any other, are you all willing to evaluate the existing system within our institution in terms of data availability and the activities that we are doing mostly manually, and try to give us a guidance of where and how AI can be incorporated and the way forward.
That's actually a very good one. I think we should take, because the point of the whole presentation itself is that this kind of thing is what should happen. Like I don't know whether I went into the details. Like the university responsibility should be bringing problems from the real world into the university, so that students will see that what they learn matters and impacts. So that's interestingly what you say has an education metric. In universities, it has a solution metric. I do not know, like for instance, how long it will take. For that, we need to look at the full graduates. I have some assumptions. One of them actually linked to the earlier point that I made about the QR code and all that as well, right? So it's more about like how much of awareness we have about the system, right? Like when we talk about the smart grid, right? We talk about like grid awareness. How much the information infrastructure have access to supply and demand, and I think Roshan has something to add as well maybe regarding this. So definitely we will expand on that, but bottom line is we need to have an awareness about these networks, right? So I would encourage we bringing it into MARC and maybe other systems, but as a person who is involved in some of these strategies, maybe Roshan.
Yeah, so anyone who is into the government sector and having data and having challenges in gathering data. So if I'm part of the national AI strategy. So what we are discussing is if you want to do anything with AI within the government sector, first thing is to collect data, like or so this is something of very much of our interest. So even we can work out funding opportunities, ways of doing this. So please getting that 100% is something that we are interested. But the problem what we see is even government sectors where data is available is they are not very willing, and the way the culture we are not very willing to share and use it for research. So things like, for example, now I don't know if anybody here is involved, the statistics that the census. Even recently they have collected really large amount of data, spending I think 30 billion rupees using tabs and also devices. 30,000 tabs they are used for year. They collected the census data. But lot of data. But the data that is shared is very limited.
It's all locked up.
Yeah, the rest are locked up because the importance of it, how we can use it now, particularly with AI, how we can use it to the betterment is a lot of unknown. So yeah, so anyone interested?
Absolutely, just to add to that, because I think it's such an important topic. That's why I said like tons and tons of times throughout the presentation about data is money, right? Because always people get distracted by the shiny, sparkly stuff, but the attention to details is what matters, and data actually is the cornerstone for that, right? So clearly, and just to add to the sort of reluctance to data sharing, I remember like when we got the IDRC grant from Canada, one of the primary conditions was to share data. Because it's a cultural shift that we need here, right? Like in many countries, we have this sense where like we are okay saying like, this is our data, find holes in it, find big holes in it, let's improve it, right? So that attitudinal change also is kind of connected. So in a way, much like Professor Rage, like completely, not only like I agree, but I kind of commend your sort of like approach to it as well, because that's something we have dealt with many agencies. We have found as a sort of an obstacle, right? Because what point is data if there is no access to it? Right now, USA, for instance, during the pandemic, yes, pandemic was going on, all that stuff, let's say is true, or whatever. If you go and look at the Johns Hopkins and other data sets, right, you have such high resolution data. So everybody knows what's going wrong or right. That's fine, right? Because it helps people. Right? So I think probably promoting, I'm sure that Professor Akhil and I think Dr. Ramesh and everybody's team, coupled with MARC and many other centers, I think what we should do is probably one, show the importance of data sharing in the AI culture, because that's the only way AI can be effectively used here. That's why I even mentioned the QR code thing, right? Because now, remember, exploitation is also a slippery slope, so you have to keep that in mind. So this is not about privacy information where we keep track of how everybody is going around everywhere. No, that's not what we need. We need to maintain data anonymity, then track it. Right? So definitely, I think you have contact details of both the Professor Akhil, myself as well as the MARC team. So we highly encourage you to continue this discussion in the future. We are definitely interested, and it has a multidisciplinary flavor written all over it. Yeah.
This is more of an industry question.
Sure.
So the industry I'm working on is more of a consumer-based economy, consumer-based industry. So it's using tons of consumer-based patterns, behaviors to exploit the consumer at the end.
Yes.
So the thing is where we draw the line.
Yes.
Then regulation we need, I think in the countries like UK they have some regulation.
Yeah.
So where we draw the line? That's the big question.
No, that's completely true. Like that leads to the last slide as well, right? That's the point. Like when we talk about anything, any good thing, quote unquote thing, is exploitable, right? So this is exploitable. Like that's why I said like somebody is thinking, well, let's get the data patterns and like optimize the transport sector. Another fellow is thinking, this is a nice way to track people and do something like advertising more. Who knows what, right? So there is always the bad actors part, right? So regulation and all these other things need to come into play, right? So for instance, I noticed, like I didn't even put it on the slides here, there was a particular study done on, probably it was a Nature study, where again they had used mobile usage patterns to detect some other problem, right? So obviously these things have privacy concerns, right? So therefore, that's why I said, like when you give too much power to few big corporations, that's obviously going to create huge problems down the lane, right? So in a way, this kind of motivates us to do something, right? Rather than just rely on solutions coming from, as we say, big tech, right? Of course, we can't like be independent of that world, right? But we need to be aware of it. So completely on board with that, and to be honest, I don't want to go into details, but like that particular thing has been happening even without AI, right? It's just that maybe AI is making it easier for these people. So the point is, the need for regulation is much higher, right? So I mean, it's like this, right? Whenever things become murky, that's when area expertise matter, right? So the problem is when we have regulators, auditors, and things like that, are these people experts in there? So that's again the reason why you need this sort of AI plus X degrees or project-based learning or integrated study, because somebody is going to come and, like audit or do whatever is going wrong in the, let's say, whatever system, communication system. They need to know the stuff too, right? So therefore, having that sort of integrated approach is an absolute must.
I think we had like a similar question from as well, where he was questioning about the ethical boundaries of AI. Where he was asking whether there's a watchdog entity component setting ethical boundaries.
Yeah, exactly. The problem is that the watchdog itself has to be watched as well, right? because otherwise it will end up becoming Big Brother as well. But the point is, I'm trying to remember. It's eluding me. Like people had used like something to track human activity inside homes or whatever, like heat signatures, Wi-Fi signals to track human activity or whatever, right? So the point is, you can just go overboard and overboard. The point is, obviously things are going to happen. The world is not perfect. So the world was not perfect earlier, and the world will remain imperfect after. So that is something we need to understand, right? There's no way out of it. We just need more smart people to care about the problem, right? And be aware.
So if we have another question, we can have this one more from the audience. And until that, I'll just read out the last question from Zoom. So, how can PhD holders enrich company standards and uphold efficiency and collaborate with industry professionals with gaps between aspects such as practical knowledge and financial literacy?
Yeah, so the point I would like to make is, it's kind of like the threefold approach I had with AI, right? So all AI is not the same, all PhDs are not the same, right? So we need different people working at different layers. The main premise of my learning model is that we allow each person to be their expert, right? So therefore, if you have a guy who is only interested in abstract theoretical things, let him be. Let him do that stuff. But there is tons and tons of people who like to relate it to the industry and project-based learning and things, right? So probably one thing we need to do is probably like that. We are just starting with MARC and other centers. Hopefully, gradually, because we do have like great problems, the intellectual communication problems, all these kinds of things. So, for instance, if we stimulate growth in a certain way, there might be more enticement for people to stay within the country. Because I don't believe in like forcing people to do this. I believe in motivating and encouraging people to do things or not do this, right? So therefore, in this particular case, like if you take centers like MARC or any other place, and you offer PhDs like for practical solutions in this way, that would be a PhD program, right? There you go.
Thank you so much, sir. If there's no more questions, I think we can conclude. Thank you so much, Professor Khan, for the time and for having such an engaging session. Thank you so much. So, yeah. Alright, I think we are coming towards the end of the session today. So this was the 6th lecture that comes under the lecture series celebrating the Diamond Jubilee of the Faculty of Engineering of University of Peradeniya. So I would really appreciate all of you being here and also taking part in this amazing event. And I would like to call upon Dr. Narendra to present the letter of thanks. Thank you very much.
Okay, good evening everyone. On behalf of the Faculty of Engineering, University of Peradeniya, and as the coordinator of organizing committee of the Diamond Jubilee lecture series, I'm truly honored to deliver the vote of thanks for today's remarkable session. Our deepest appreciation goes to Professor Roshan Godaliyadda for delivering an inspiring and intellectually stimulating lecture on AI-driven multidisciplinary research transforming the engineering landscape. Your insights into the transformative power of this artificial intelligence across engineering disciplines spark more interest and conversation among all of us today. Thank you, Professor Roshan Godaliyadda, for sharing your expertise and vision with such clarity and depth. I extend our sincere thanks to all the distinguished engineers, professionals, academics and students who joined us with this evening today, both in person here at the auditorium and also online via Zoom. A special word of gratitude to the ISL for generously providing this excellent venue and also for supporting this landmark lecture series throughout. Finally, to all the participants, thank you for being a part of this journey of academic celebration. We look forward to welcoming you to our upcoming lecture as we continue to make the faculty's 75 years legacy of excellence. Thank you once again and have a pleasant evening. Thank you very much.
Point of